All right, so this section will be about propositions and truth tables, truth values. Also, I'm going to be talking about inverses and contrapositives and that sort of thing as well. So a proposition is any statement based in that's a complete sentence. Ducks have webbed feet. They can be true or false. This one happens to be true. You could say or you could say, no, you don't have to say blondes. You can just say blondes are dumb. And maybe if I put all in front of that, because I used to be a blonde before I became brown, before I went gray and bald, so whatever. That's false, obviously. So it could be either one, but any of those are propositions. Okay, so based on that proposition, if we call this P up here, so when I look at a table, that thing could be true or false, right? So right off the bat, so there's my statement P. It could be true or it could be false. Then if I say, well, what if it's not P? So in other words, what's the opposite of P, basically, right? So if P is true, then not P then is false. If P is false, then not P is obviously true, right? And then what if you not P, which is the idea of it's a double negative, right? Well, a double negative implies a positive. So if it's not that, then it must be the original, which is P, which is, well, it's true or false in whichever case it happens to be. So in our case, okay, there it is. Our P was true, so ducks have webbed feet. Okay, the not of that and the negation of that is ducks don't have webbed feet. Well, that's false, obviously, right? And then if you double negate that, so that's a little trickier to write the way we wrote it here, but we'll look at some more of them in general as we go along. We're going to look at these truth tables. It's kind of an interesting thing. Now, we're going to look at, we've talked about this before in probability. Whenever you heard the word and, we knew that things had to get smaller, right? Because both things had to be true at the same time. That's going to be true here as well. So we get into some things later on, and we're going to see that P and Q, we call it a conjunction, but it's true only if they're both true. Okay? So you could have a truth table that looks like this. We say P and Q here and here, like so. Okay? And then P and Q, we would write like this. Well, not like that, I guess, like this. And so if this was true and this was true, well, they're both true, so P and Q can be true. But if this is true and this is false, then the conjunction of them or them together would be false. So for instance, it'd be the idea of, look, I want a person with blue eyes and blonde hair. Well, hey, this person has blue eyes with brown hair. I literally didn't say that. Okay. Well, this person has blonde hair and green eyes. It's not what I said. So they must both be true. I'm having a rough day. Blue eyes and blonde hair. Okay? Now, what if you have one but not the other? That doesn't work for me. And what if you have neither? You have brown hair and brown eyes. Yeah, literally that's no good either. That's no bueno either. So, gotta be careful of those things. Obviously, you can't have them be excited. Now again, to me, that's the most obvious one, is to pick something that makes sense to you. For instance, blue eyes, blonde hair. And if you say to yourself, look, I need to have someone with blue eyes and blonde hair, you shallow weirdo, then that's the only thing that would make this person happy. Okay? Everything else is no good. Then, by the way, that also is the idea of, listen, if you'd be happy with blue eyes or brown hair, or blue eyes or blonde hair, that'd be any of these guys, yes? Any of those would work, because any of those have blue eyes or blonde hair. But that's the only one that has both. Okay, this one here is just, it's no good for anybody. Okay? Yeah. Now, we can do all kinds of some pretty interesting things like this. Now, when I say or, it's the same basic procedure. So here's P, here's Q, and then here's P or Q. Now again, or gives us more advantages. So if this is true and this is true, then is P or Q true? Yeah. They both happen to be, but yeah, one of them at least is. So this also works. At least one of them is true. This one also works because at least one of them is. But this one is no good. Okay? It's a pretty easy deal when you look at them that way. We'll look at some more as we go along. Okay? Excuse me. Okay. Now, if you've ever heard of the word conditionals, which you have because we've done probability so far, right? Conditional probability said if this happens, given that this has already happened, what's the probability that this over here happens? Okay? So when you look through it, what had to happen first? Well, the first thing to happen. So we're going to state it this way. If P, then Q. Okay? And so what do I mean by that? Well, I mean that if one is true, then so when we bust through this thing here, you're going to see that you'll see how it works in just a second. Well, so but the idea of this was, so if you call, then I'll come over or something like that, right? So you could phrase this in a number of ways that make sense to us, but we'll do an example of that in just a second. I want to do one that's a little more abstract first, maybe. I'm going to pause this for just a second. All right. One of the ones in your book that I really like is about the politician, and it says that if she's elected, the minimum wage will increase. Okay. And so if she's elected, that's my P. Minimum wage will increase. That's my Q. And so if you think about it, here's P and here's Q. Now, what I'm going to do, okay, is I'm going to go through and rearrange them in any order I want. So maybe I do this. So she's elected, she's elected, she's not elected, she's not elected. Okay? She's elected and raises the minimum wage. She's elected and she doesn't raise the minimum wage. She's not elected, but the minimum wage goes up anyways. She's not elected and the minimum wage didn't go up. Okay, so here's the game. If P, then Q. That's what I want to know. Okay, so she's elected, then it went up. That's definitely a true statement. If she's elected and it doesn't go up, that's a false statement because that's not what she said she would do. She said she would raise it. Okay. Now this one here, if she's not elected and it still went up, well, she wasn't lying to you, in other words. She didn't make a campaign fib because she didn't get elected, so it doesn't hurt anything. And the same thing is true down here. In other words, we're rating our politicians based on what they said. So this person said, if I'm elected, I'll raise the minimum wage. The only way that she had any aspect of that was this, is if she got elected. Okay? So if she got elected, given that she got elected, she either raised it or she didn't raise it. In which case she's a liar here or she's not a liar up here. Okay? Assuming that one person could make that big of a difference, right? So that's the game when you think about those things. Okay? We say it's conditional because it's conditioned on her getting elected. If she never got elected, then whatever else she said is not really that big of a deal, Well, if I get elected, I'll do this, that, and the other thing. Well, you didn't win, so I don't know why you're talking, crazy person. Okay? But if she won, then she could either do it or she won and she didn't do it. Okay? These ones down here, she wasn't lying because she obviously didn't win. So, that's kind of how those will play out on those. Okay? Now, when we do these, okay, we have this idea of it's a conditional. So when we say that, we say that if P, then Q, right? That's the whole point. If P, then Q. But what happens if you do some different things with that statement? What if you say if Q, then P? Well, that is a wildly different scenario, right? So if I, like for instance, if you call, I will come over. Okay, well, that's fine. So that seems pretty legit. If you call, I'll come over. But what if I say this way? If I come over, then you will call. Well, that's weird. Why would you call me? I'm already there. That doesn't even make sense. It's just an oddball way of saying it. It may or may not make sense. We'll look at some more coming up as we go along. What if I say it like this? If not P, then not Q. Okay, if you don't call, then I won't come over. Well, that makes perfect sense. Sure, yeah, obviously. If you don't call, you're probably not home, so I'm probably not going to come over. So, sure, that makes sense. You could also turn it inside out and say, if not Q, then not P. All right, in which case, what would happen there? Well, if I don't come over, then you won't call. Again, doesn't really make any sense in that situation. Okay? We call this the conditional. Okay? We call this the converse. We call this one the inverse. We call this the contrapositive. Okay? And that's just how that's how they all work through the things. Okay? So we'll do some, and we'll kind of work through them and see how it works out. We'll do some examples of them. I think that's just way easier. So, if they have the same truth value, when it's all said and done, if they have the same truth value, we say they are equivalent. We say they're equivalent statements. They're logically equivalent. Okay? So we're going to do several of them, see what you think about them. Going to play it by ear, see where we end up here. So this is, for instance, number 63. If pigs can fly, then fish can brush their teeth. Okay? If pigs can fly, then fish can brush teeth. Right? Now, we're not going to assess that for truthfulness, per se, but we want to talk about the hypothesis and the conclusion, okay, and state their truth values or not, okay? And then we're going to talk about, we're going to rewrite those back and forth in terms of contrapositives and so forth. So here's our hypothesis. So if pigs can fly, then the conclusion is this bit over here. Okay? Now, if pigs can fly, well, pigs can't fly, so that's false. Okay? Then fish can brush their teeth. Fish also cannot brush their teeth. So those are both false statements, so it's false. Okay? Not very hard to figure that one out. It's not that hard to do. What I really want to focus on, though, is I want to write the converse, the inverse, and the contrapositive. So the converse, of course, is if fish can brush teeth, then pigs can fly. That is the converse. The inverse, if pigs can't fly, then fish can't brush. And the contrapositive, if fish can't brush, then pigs can't fly. Okay? And again, you're just stating it out in that effect, in that manner, is to see where you're ending up. Okay? Now, okay, so here's a statement. It's a proposition for us. So the hypothesis, butterflies can fly. Well, that's a true statement. Okay? So that is a true statement. Then butterflies are birds. Well, that's a false statement. So we're saying this part implies this part. Well, that implication is false. So we say the implication is false. Just because the first part is true, if the second part is false, then the implication is false. Okay? In that regard. So what we're looking at is this. We're saying that here's P. P in this case happens to be true. Q happens to be false. So this and this right here, boom, this is like the politician that gets elected but doesn't raise taxes, or not raise, doesn't raise the minimum wage. So therefore P then Q is a false statement. The implication is false. Okay? So that's that situation. Okay, here's another situation where we want to make a truth table for P or Q or R, or P and Q and R. Okay? So again, here's the deal. I'm going to lay it out like this. Okay? So what I'm going to say is, okay, we know from probability that each thing, P and Q and R, each of them have two options. That can be true or false, right? And so because we know that, it's 2 times 2 times 2, there's 8 possible combinations, yes? And so we know going in that P could be true 4 different ways, could be false 4 different ways, okay? That means that Q could go, I'm going to do it like this, I think. And then I'm going to do Q every other one. Or, whatever I'm saying. And that should do the trick for us. Okay? I think you'll find that I have hit them all as you go through it. Now, I would be happy if P or Q or R, if any of them were true. So that would work. So would this one. The only one is a fact that wouldn't work is the last one, yes? So there should be 7, 1, 2, 3, 4, 5, 6, 7, 7 of them. And then 1 false one, right? P and Q and R true. The only one of those that's bueno is this top one. The rest of them are all false because I can't have any falses for it to be a true statement where P and Q and R are all true. Okay? Now here's one more table-wise. All right, suppose I want to make a truth table for P or not P or Q. So first thing I start off with is I need a column for P's. And whatever P is doing, not P is doing the opposite of that. Okay? And so because I really don't have 3 things, I really only have 2 things, I'm just going to do this. Right? And then Q, of course, something along these lines. Okay? That is, Q is true when P is true. It's false when it's true. It's true when it's false. And it's false when it's true. You with me on this? Now, what I need is I need one of these 3 to be true. Okay? That's what I'm looking for. So P or not P. Either of them to be true. By the way, wouldn't that be, I don't know, all the time? Or Q. That's right. So on the first one, well, that's a true, so this is good. There's a true, so that's cool. There's a true, so that's nice. And there's another true, so that's also nice. So it's 100% chance of that happening. Okay? What if I did... let's see here. R or P or not S. And you're like, wait a minute, not S, that's basically the same as saying S. That's true. I shouldn't say let's do or, let's do and not S. This truth table is almost verbatim what we did just previously. So there are 3 things here. Not S, well, that feels weird because whatever S is, this would be the opposite of it. But since I don't know what S is, it doesn't really matter. True? So what I'm going to do here is I'm just going to go 1, 2, 3, 4. 1, 2, 3, 4 on these guys. And then P, of course, is we're just going to do... You can do any pattern you want, but that's the easiest pattern as far as I'm concerned. This is almost identical. Well, this part is identical to what I did before. If it would make you happy to do false, true, false, true, false, true, false, true, you'd still get them all. They would all be there. This false, false, false would have ended up right there, and then this true would end up. It's all the same deal. Now, what I need to happen is this. Okay? I need to have one of these be true at the same time that's true. Okay? So, here's a true. That's a true, so this is a true statement. We've got a false statement on not S, so this one's going to be false. As a matter of fact, that will be that way on all of these guys. But here we go. We've got a true here. So look over here. Is one of these true? Yes. So we're good. This one is true. Is one of these guys true? Yes. This guy is true. Is one of those? No. No, indeedy. And so those are the ones that would make that truth table a happy and wonderful statement. Okay? And there's just one last thing I want to talk about, and then we will call it. All right, and lastly but not leastly is the idea of sufficient and necessary. Okay, in logic, they're kind of big deals, and it's not very difficult though. So you write it this way: P is sufficient for Q, and Q is necessary for P. Okay, so here is a quote from Tupac. If you believe, then you can achieve. Okay, well, here's your P, here's your Q, right? So P is sufficient for Q. So believing is sufficient for achieving. Okay, Q is necessary for P. Achieving is necessary for believing. Okay, and so that's what they want when they see that. That's all there is to it. Okay, that is something that you will see occasionally in a logic class. They'll write it that way. In a math class, once in a while, we'll see that too. Not in this level of math. We talk about the underlying structures of calculus and how it works, like with continuity and things like that. Continuity is a big deal, and for that to happen, there are some things that are necessary for that to happen. Okay, so there's a lot of logic, for instance, in computers and in mathematics that are based on this logical structure. Again, all we're doing here is just giving you some ideas of how it works. So don't stress it too hard. Mostly what you'll be doing is a few truth tables and writing the inverse and contrapositives and so forth.